So let's go ahead and see another example of how to sketch. Once again, it does not matter what order you find the three things, just find all three. So I'm going to start with x-intercepts for this problem. And if you wanted to, you can just make your sketch and just plot them right away. So our x-intercepts, we've got this term that has an x, so 4x squared. If that's the only way to make that 0 is if x is actually 0, because 4 times 0 gives you 0. Multiplicity, remember you look at the exponent. So the exponent is 2, so the multiplicity is 2. Therefore, this is going to bounce or touch. Our next one, we want 3 minus x to equal 0. That means x has to equal positive 3. Multiplicity is 1. Therefore, this one's going to cross. And then our last one, we've got x plus 4 that we want that to equal 0, so that means x has to equal negative 4. Multiplicity is 3. Therefore, this is also going to cross. So I'll go ahead and plot all those. We've got 0 is a little bounce. Negative 4 is a cross. And 3 is also a cross. So let's go ahead and find our y-intercept. So y-intercept, I'm going to replace all the x's with 0 and solve. Well, hopefully you'll actually recognize that if there's an x-intercept at 0, the y-intercept also has to be 0. And that makes sense because we have 4 times 0 times 3 times 4 cubed. Well, since there's one term that's 0 that we're multiplying by, everything is going to equal 0. So our y-intercept's already there. So let's go to end behavior, because end behavior is going to be especially important on this problem. And there was something on that last video I was said a little incorrect, or at least I can see a misconception coming out. What I do is I always keep the x's, but I ignore all the other terms inside the parentheses. So like this 3 I ignore, but I keep the negative on the x, and then that 4 I ignore. Okay, that plus 4. So we're going to multiply everything else though. So we'll have 4x squared times negative x times x cubed. Notice I keep the exponents. And so that will be a negative 4x to the, there's 2, 3, 4, 5, 6. So the right arrow will go down since it's negative, and it's an even degree, so the left arrow will also go down. So both arrows are going down. We're going to cross through and then bounce and cross through again. Now remember, this is a sketch, so you could have sketched it so it was like more dramatic, so it looked more like this or something, where the peaks weren't quite the same height. We don't know. We're doing a sketch. Both are correct. Let's do another example in this video really quick. So x-intercepts. I'm going to go ahead and make my graph. I'm going to go ahead and just find my x-intercepts by setting each factor that has an x equal to 0. And then multiplicity will tell me if it bounces or crosses. So it's even multiplicity, so it's going to bounce. So I have my x minus 3 equals 0. So x equals 3. Multiplicity on this one is odd because it's a 1. Therefore, this one's going to cross. And then x squared plus 3 equals 0. Well, watch out for something like this, because when I take the square root, we're going to get a positive or negative imaginary number. We can't graph imaginary numbers, so you just ignore that one. Okay? So we only have 2 real x-intercepts. So we got 3, which is a cross, and negative 1, which is a bounce. Okay, I'm going to find my y-intercept by putting in 0 for all the x's. So that's 1 squared times negative 3 times 3. So that's just negative 9. So I've plugged that all in, and I go ahead and just, on the negative y-axis, I go ahead and put my negative 9. Okay, now that I've whipped through those really quick, let's go to our end behavior. So end behavior, once again, it's like I'm ignoring the terms inside each parenthesis that do not have an x, so I only keep the x's inside the parentheses, and then I keep anything outside the parentheses. So I'll have x squared times x squared. And that just gives me 1, 2, 3, 4, 5, so x to the 5th. So the leading coefficient is positive, so the right arrow is going to go up. And the degree is odd, so the left arrow switches direction, so it's going to be down, up. So I go to my graph. Farthest left point is going to go down. Farthest right point is going to go up. And then I connect the points so that this one's bouncing, so I do not go through the x-axis. I go to -9, and then I cross through at 3.